Okay, I haven't been on for a few slides here. I know you got into the roots and that, so and the answer is here on this slide deck, but I did want to explain this to you just so you could have some verbal explanation and make sure it makes sense to you. There are actually two options here for this one. We could actually square this thing if we wanted to. We could say, you know what, 2m minus 5 times 2m minus 5 equals 12, and then we could go to the work of squaring it, and we could go to the work of bringing the 12 over, and then we can go to the work of trying to refactor, and it might not even refactor. But there's a quicker way to do it, and that's by taking the square root. See, if I take the, whatever you do on one side, as long as you do it on the other side, it's okay. So if I take the square root on this side, I have to take the square root on that side, and that's okay. 2m minus 5 squared, if I take the square root, I just get 2m minus 5. So that works nicely. But what you got to do is you got to take that square root of 12. Now, the problem is when you take a square root of a number, there are actually two options. Okay? So I could have the positive square root of 12 or the negative square root of 12. Think about it without 12 and the awkward square root. Think about it as 16. The square root of 16 is 4 because 4 times 4 is 16. But isn't it also true that negative 4 times negative 4 is 16? So if I use 16 as an example, we'll use a different color here. If I take the square root of 16, it is true that it is 4, but it's also true that it's negative 4, right? Because 4 times 4 is 16, negative 4 times negative 4 is 16. So I could write that as plus or minus 4. Now it looks a little awkward when it's not a perfect square because it's not a 3, it's not a 4, it's just the square root of 12. But when I'm taking the square root of both sides, I have to remember there's a positive and a negative option. Because the square root of 12 times the square root of 12 is 12. Negative square root of 12 times negative square root of 12 is also 12 when we multiply it together. Okay. So what I have here, then I can just isolate. So I can bring the 5 to the other side. 2m equals. Now what happens often is when this negative 5 comes over, it becomes a positive, and we don't usually put it at the back, we usually do this. Okay? And why we usually do that is because then the root doesn't drag over, we always put the whole number in front. Okay? The thing is, before we do that, what you'll notice on the slide is it's no longer the square root of 12. Because what we've done is we've gone over here, and I'll use red again. We said, okay, the square root of 12 can be the perfect square, which is 4 times the square root of 3. Remember we did that in week 10? Square root of 4 times square root of 3, 4 times 3 is 12, so the square root times the square root is the square root of 12. And why we did that is because the square root of 4 is 2, and it's 2 root 3. And it gets the square root as small as possible. Okay? And you might have been saying, why do we ever do that? But here's one of the reasons why we looked at that in week 10 is because I'm going to write this as 2m minus 5 equals plus or minus 2 root 3. Okay? And then I'm going to bring the 5 over. 2m equals 5 plus or minus 2 root 3. Let me get out of your way here for a second so you can see that. Okay. See how the, and I know I'm off screen, but see how the 5 I placed in front, but it's a positive. It's just traditionally in math, that's where it goes. Okay. And then all I do to get m is I divide everything by 2, 5 plus or minus 2 root 3 over 2. Okay. And we can leave it like that. Okay. We can leave it like that. Okay. The one thing that we can also do, and that's how it's left on the slide, but the one thing you can also do is notice that I could do this. 5 over 2 plus or minus the square root of 3. That is an option. It is correct, because what I've done is I've divided 5 by 2, and I've divided 2 root 3 by 2, but then they just get rid of the 2's and it's root 3. So that would be another way to write it, and another correct way to write it as well. But I want you to also understand there are 2 answers there, okay? No matter which way you do it, we'll stick with how they did it in the slides. We'll go to a different color. But there are actually, this looks like, well, there's one answer, that's what M is, but it's 2 actual answers. The answers are actually, whoops, I don't want to do black, I want to do purple. Okay. The answers are actually 5 plus 2 root 3 over 2, or 5 minus 2 root 3 over 2. Okay? And there are actually 2 different answers. If you actually got out your calculator and got these to be decimals, right, you'd see that that is a different decimal answer than that. I believe this decimal answer is 1.7, 1.8, 3.6. It's more than 4. It's 4 point something. Where this decimal answer is 3.6. It's like less than 1, I believe. It's like 0 point something, right? So 2 different answers, but you do have the 2 possible solutions. We'll see you later.